Welcome to qnawire.
In this question, we have this situation. So this is a surface, and then we have a basketball and a baseball, both released from a height of 1.8 meters. Okay, and then they uh, fall down, and then when they hit the surface, when the basketball hits the surface, okay, it rebounds elastically, and similarly, when the baseball collides with the basketball, the collision is also elastic. Okay, so after the collision with the floor, okay, we are given that the basketball is going to have zero final velocity, and then the baseball will be flying up. Okay, so in this question, there are two parts. We want to find the mass of the basketball such that, or no, the mass of the baseball such that when the uh, basketball rebounds, it has, and after the collision with baseball, it has zero velocity. Okay, the basketball has a mass of 0.63 kg. Okay, and then it's falling from a height of 1.8 meters. Okay, yeah, so we are going to assume that the radius of the ball is uh, much smaller than h. Okay, all right, so to do part A, okay, so first we need to find the speed of the ball, um, as before it reaches just before it reaches the ground. Okay, so step one, we find the ball, find the speed of the ball. Okay, just before uh, it reaches the floor. Okay, because we are going to use, we need this value to calculate the momentum of the ball, uh, the basketball, before it collides with the baseball. Okay, so we'll use conservation of energy. Okay, so the system we are looking at is basketball plus Earth. Okay, and so we have Ki plus Ui equals to Kf plus Uf. Okay, and then Ki is 0, Uf is Ui is mgh, Kf is half mv square, Uf is 0. Okay, so V is 2gh square root, okay, and 2 times 9.8 times 1.8. Okay, and you take the square root, you get 5.94 meters per second. Okay, and then step 2, okay, the collision, okay, we want to find the mass of baseball. Okay, so the collision between the floor and the basketball, okay, is elastic. Okay, so basketball to the basketball rebounds with a speed or with an upward velocity of 5.94 meters per second. Okay, so what happens is that we have the basketball, okay, moving up at 5.94 meters per second. Okay, we have the baseball coming down with 5.94 meters per second. Okay, I'm going to call this M1, this is big M. Okay, small m. Okay, and then I'm going to take upward to be positive. Okay, so using conservation of momentum, so since we have an elastic collision, right, we are going to use the equation for uh, this is 1, this is 2. Okay, I'm going to use the equation for, no, I'm going to call this 1, this is 2. Okay, and for elastic collision, okay, we have V2 okay, so V1F is equal to M1 minus M2 divided by M1 plus M2 V1I plus 2M2 divided by M1 plus M2 V2I. Okay, and then we are given that okay, V1F is equal to 0 after the collision. Okay, so V1I is 5.94 meters per second, and then V2I is negative 5.94 meters per second. Okay, so since the left hand side is 0, we only need to care, and the denominators are the same, so we only need to care about the numerator. Okay, so 0 equals to, so M1 is big M, M2 is small m, okay, times 5.94, okay, and then minus 2M2, 5.94. Okay, so the 5.94 can also be cancelled out. Actually, this is m. Okay, so rearranging, we have big M equals to 3m. Okay, or small m equals to 1/3 of big M. Okay, so big M is 0.63 kg, and so small m is 0.21 kg. Okay, so this is the mass of the baseball, so that the basketball would go to rest after the collision with the baseball. Okay, then in part B, we want to find the height that the small ball reach. Okay, so to do that, the first step is to find the speed of baseball. Okay, I'm just using baseball as a proxy of small ball. Okay, after the collision with basketball. Okay, so we'll be using the equation for elastic collisions. Okay, V2F is equal to 2m1 divided by m1 plus m2 times v1I plus m2 minus m1 divided by m1 plus m2 v2I. Okay, so v2f, so you can substitute the values. Okay, m1 is big M. Okay, and then big M plus small m. Okay, and then we have v1I plus small m minus big M divided by big M plus small m. Okay, v2I. Okay, so just to recall, v1I is 5.94. Again, upward is positive. Okay, and then v2I is negative 5.94. meters per second. Okay, so you substitute the numbers. 2 times 0.63 divided by 0.63 plus 0.21, 5.94 plus 0.21 minus 0.63 times negative 5.94. Okay, and you calculate this, you get 11.9 meters per second. Okay, and then step 2, okay, find the height that the baseball would reach. Okay, so to do this, we'll be using conservation of energy. Okay, the system is baseball plus Earth. Okay, we have Ki plus Ui equals to Kf plus Uf. Okay, so Ki is half m V2F square plus Ui is 0, Kf is 0 plus mg h. Okay, so the m cancels and h is V2F square divided by 2g. Okay, so you have 11.9 squared divided by 2 times 9.8. This is 7.2 meters. Okay, so this is the answer for part B. And that's all for this question.